There you go.
Good evening. Everybody. Good evening, everyone. No problem at one next time. I hope you can hear me okay. And if you just click once, please, it should actually say what we're going to do today. So this is webinar 71. No, I haven't written so many, and we're not going to worry about why it's number 71. But the content and revision is from the first little chapter in our book here. I'm holding my book up, but of course you can't see me, so we'll put that down. And we're looking at planet Earth. You might think in an astronomy course, why are we looking at geography? Well, we need to know about coordinate systems on the Earth to be able to talk about coordinate systems on the sky. And that we'll be looking at in a few weeks' time. So we've got three little bits of work to do here: the Earth's structure, longitude and latitude, and the Earth's atmosphere. So let's get stuck in. Alastair? Right, a few facts and figures first of all. Now, don't try and write all this down because you will have the presentation recorded, and it's all in the textbook. The Earth's diameter is 13,000 kilometers. It doesn't mean a lot at the moment, but we're going to use that to be able to compare it with other planets later on. And its shape that we do need to know, this has been in every astronomy syllabus that I've been involved with. It's a slightly squashed sphere. It's an oblate spheroid. And what I'm going to invite you to do is to think of a space hopper. Now, if you don't know what a space hopper is, if Alastair presses the button, a little space hopper might appear. And there we are. That's a space hopper. Some of you might have had those when you were youngsters. The youngsters among you might be looking forward to having one when you're older. There's all sorts of names for them, but there she is, just leaping in. So it's a big ball, but squat. Inside the Earth, we've got basically that we're standing on now. We've got the mantle, which is a kind of gooey mess and a mixture really between molten stuff that comes out from volcanoes and rocks. We've got two cores, an outer core and an inner core. Now, again, you might be thinking, well, why is it that we're studying this? Well, the outer core is very important because it consists of charged particles, mostly electrons, that are moving, and that gives rise to the Earth's magnetic field. And you might be thinking, well, why do we want to know about the Earth's magnetic field? Surely that's physics GCSE. We need to know about the Earth's magnetic field because it's responsible for one of the most beautiful astronomical phenomena in the world, the aurora. And so we'll be looking at that later on. Some of you might have been lucky enough to see the aurora. Very, very rarely we can see it at sort of latitudes in England, but certainly if you get up to Iceland or Sweden, good chance to observe the aurora. So we've got the four internal layers. So let's not worry too much about those. We've got oceans covering probably, now it depends on who you read, 70%, maybe 80% surface. We're not going to deal with that and debate it. There's a lot of water. Interestingly, where does it come from? That's something to look at again a little bit later. You can see, I think, that this planet Earth module is really a springboard to lots of others. But obviously, because we're dealing with a kind of molten ball that still hasn't recovered from, and solidified, we get towards the center, the density of matter and the temperature going up. So that is something that we'll look at again later. Thank you, Alastair. I don't think Alastair heard me oh, there we are. Right, so the outer core is a liquid, as we've mentioned, and that contains the charged particles. The inner core is solid. It's hot enough to be liquid, but the pressure's so high, if you try and squash a liquid, well, it's impossible on Earth, basically, but you get a solid, and the inner core is a solid because the pressure due to the outer layers is just so high. And you may just like to know, and this is more geochemistry, I suppose, that the core is mostly made of iron and nickel, very common elements in the solar system. And the crust is mainly rock, which we're going to to call silicon dioxide. There are others, but silicon dioxide is the main one. Questions could come up on this. A lot of students in the past, I think, have thought, oh, the planet Earth, we won't get many questions on that because it's the Earth and we're studying astronomy. Well, you'll be surprised just how many come up. Right. Okay, thanks, Alan. There's just a summary, and that's taken straight from, what is it, page 3 in the book. So there we go. That's all to scale, relatively to scale. You can see probably the water, the blue. You may not be able to see the atmosphere of oxygen and nitrogen too well, but it's there, and it causes effects, as we shall see shortly. Right, next slide, please. Now, the atmosphere is very important to us, of course, and we know the obvious advantages, allowing us to breathe and giving us sunsets and rainbows and weather and things like this. But one important thing that you ought to be aware of, and in a way, I don't think the book and therefore the course will emphasize this enough. The atmosphere bends light. It goes not in a straight line through the atmosphere, but in a slight curve. And this is called refraction. For the more mature students, you'll remember this from O-level physics, as I do. And light doesn't quite travel in a straight line through the atmosphere. It bends towards really the vertical, I suppose. So anything close to the horizon actually appears higher in the sky than it really is. And this is why, if you've ever seen the sun under ideal conditions, either setting or rising, the bottom part of the sun seems to be lifted up, and that's why it looks pear-shaped. So a pear-shaped sun at sunset and sunrise is all to do with atmospheric refraction. It also makes the stars appear actually higher than they really are, because the light entering the eye and the brain think that the line is straight line. So we'll maybe have some more to say about this a little later on in the course. But atmospheric refraction, I suggest strongly that you just have a look at that. Just Google atmospheric refraction and you'll see a little bit more about that. You might even get a nice image of the sun looking pear-shaped. Thank you, Alastair. And we'll need a couple more clicks. Thank you, Alastair. And this young lady is saying, wasn't there a question about that in last year's paper? Now, some of you have used all these webinars from the past. You'll notice some of the images and the teachers and so on that I keep using. But this is a new one because this is in 2023. Let's get the year right. Wasn't there a question about this in last year's paper? That's this summer just gone by. And the teacher's saying, yes, there was a question. So let's have a look at it. And this is new to everybody. I've still got the same. Thank you, Alastair. Right, this is from 2023. The figure 5 shows a photograph of the sun's disk taken just before sunset. There it is. The sun's disk does not appear to be perfectly circular. I think at first glance, I would say that's a circle, but we're told that it isn't, and we therefore have to think it's pear-shaped. Okay? So we've got to explain, so we've got to give reasons why the sun's disk doesn't appear to be perfectly circular. Not the easiest of questions to answer. This is question 3. For those of you who don't know me, I will criticize questions and find out mistakes with great regularity, not because I'm fussy about that, but because of Edexcel's inability to follow the specification and ask questions that aren't ambiguous. However, not for now. So really, there would be a mark going. I've not got an answer here. There will be a mark going for the fact that the light from the sun is refracted by the Earth's atmosphere, and therefore that parts of the sun are higher than they really otherwise would be seen. And that's where your 2 marks come from. There's a little, I think you can see grey too.
Sorry, can I ask a question? So, I mean,
of course.
The sun isn't a perfect sphere either because it's spinning and it's plasma, it's not solid. So it is a bit squashed, isn't it? Like Jupiter and Saturn. So what if you start talking about that in this question? Don't they give any marks for that?
There was nothing in the mark scheme about that. This is again why it's not it's too vague a question in a way.
Yeah, I mean there are hints like the sunset and and appear is there twice. So they are trying to steer. But yeah, you're right.
A valid answer would be the sun doesn't appear to be purposely circular because it isn't. Now, all right, the sun is actually the most spherical of the sun, Earth, and Moon, but the examiners don't really know that. But it's looking at atmospheric refraction. Right, thank you, Aniko. Chip in, everybody. Be free to chip in. We'll answer questions. It's supposed to be a kind of more open house today. Now we're up and running. Let's go with it. Right. Okay. Next slide, please, Alastair. We'll be on to some more past questions shortly. Now, what have we got? A little bit about latitude and longitude. This is important. Now, on a map of the Earth, we've got vertical lines and horizontal lines. They're not actually lines. You might be able to see them. You might be able to think, hang on a minute, I can see some blue lines there. But they're really angles from the center of the Earth to another couple of places. And that's important to stress to start with. So can we have the next slide, please? Here we are. Here's latitude and longitude. Just difficult concepts in a way. You've got to imagine that you're at the center of the Earth. So that's that blob between 85 degrees and 78 degrees. Don't get them mixed up, latitude and longitude. Latitude is the value of the angle between a point on the Earth's surface and the center of the Earth and another point on the surface, which is further north or further south. So the lines of latitude are the sort of, if you like, they're an onion. If you're cutting the Earth in half and then chopping an onion, you would go through the lines of latitude and longitude. As opposed to with longitude, you need, for that, you need a chocolate orange. So you might like to treat yourself after this to a chocolate orange, and you'll see that the segments are very different in style. It's the same thing with latitude and longitude. I think the important things are, where are the zeros? Where are the important lines of latitude and longitude? So let me just point out the zeros. The zero in latitude is the line through the onion that you would cut in half. So that's the horizontal cut, and there you are. The equator cuts the Earth in half across the middle. For the equivalent of longitude, that's a little bit more arbitrary, you've got to chop a line through the North Pole vertically to the South Pole. And then you can go either further east or west and so on. But the zero of longitude is what we call the prime meridian. And that is the line of longitude through Greenwich, through the observatory in Greenwich. I suppose the English astronomers in those days said, well, we sort of found a way to determine longitude, so let's have the zero of longitude here in Greenwich. And you can actually go to the observatory in Greenwich, and there is a brass strip. Again, it looks like a line, but really it's representing an angle. And you can stand with 1 foot in the north. No, not in the north. 1 foot in the east and 1 in the west. So that's something to think about. Maybe at half term. Right, next slide, please, Alastair. Now, there are some very special latitudes that we need to know. And here's where the geography is now beginning to merge with the astronomy. There are special latitudes. The equator has a latitude of 0 degrees, as we've just seen. So the geographical poles are at 90 degrees north and 90 degrees south. So we always put the N or the S in, or write the words out, to show that this is latitude and not something else that we'll deal with the stars, something called declination. Now, the two further special lines of latitude are the Tropic of Cancer and the Tropic of Capricorn. And I'm sure you've seen these on a map or on a globe. These are the limits at which the sun lies directly above the Earth. Now, let's think what that actually means. It's quite fortuitous that in 2 days' time, the sun is going to move through the equator. It's going to go from the northern hemisphere to the southern hemisphere. And that marks the important day on Saturday of the autumnal equinox. I think it is actually on the 23rd of September this year. So that's the autumnal equinox. So we're supposed to have equal night and equal day. So after September the 23rd, we're going to have 6 months where it gets progressively darker and then lighter again. And then in the summer, we're going to have from March to September, it's going to get progressively lighter and progressively darker again, ending up in September. So the sun makes, if you like, we are moving around the sun. The Earth is moving around the sun. And these 23.5 and 66.5 degrees are all to do with the Earth. But basically, you can think of a stationary Earth and let the sun move. And therefore, it moves between latitudes of 23.5 degrees north and 23.5 degrees south. So if you are, say, at a latitude of 23.5 degrees south, when the sun is lowest in the sky, when it's directly above the Tropic of Capricorn, that's when basically you would have a much, much longer day than we would have in the northern hemisphere. So this is why the kind of it's summer in Australia and South Africa when it's winter here, and vice versa. Now, the other two are the Arctic and the Antarctic circles, and these are at very high latitudes, 66.5 degrees north and 66.5 degrees south. Now, if you are at the, say, Arctic circle, 66.5 degrees north, and please look at all these later on a globe or a map later on and familiarize, so they're actual places and locations, not just names of things. If you're at the Arctic circle, 66.5 degrees north, and you are, say, let's say it's at June the 21st, so the midsummer, you will not be able to see anything further south than the Antarctic circle. I think that's right. Yeah, there we go. So the Arctic and Antarctic circles, it says, oh, can we have the next slide, please, Alastair? It says on the next slide a little bit more there, that the angles are related to the 66.5 degrees tilt. Now, we've just got to be careful here. We all know from primary school that the Earth axis is tilted. And we know that that gives us the main reason why we have different seasons, as we've just been talking about. But a lot of people say, oh, it's tilted at 23.5 degrees. And they're only telling us a little bit of the information. To what? You need two lines to form an angle. So it's no good saying, oh, the Earth's tilted at 23.5 degrees. That's what you see in the textbooks. That's what you see on the BBC weather forecasts when it comes to equinoxes and solstices and so on. What it really is that it's tilted at an angle of 66.5 degrees to the plane of its orbit. It's tilted at an angle of 23.5 degrees to an imaginary line that is at right angles to the orbit. So if you imagine the flat plane of the Earth, this is a kind of sort of glancing diagram showing the Earth and the Sun here. So if you can imagine that that plane of the Earth's orbit is the horizontal, for some strange reason, we tend to quote the angle of the Earth's tilt, 23.5 degrees, to a line at right angles to that. And I think you can see for the diagram, I think I've tried to show this. I think I did it when I wrote the book just to make sure that the angles were about correct. So if you draw a vertical line, you'll find through the middle of the Earth that the angle between the tilt and the vertical line is 23.5 degrees. But if you want to be a little bit more correct, it's tilted at 66 degrees, 66.5 degrees to its orbit. And you might like to think more about that. Right, next slide, please, Alastair. Sorry, I'm not giving much pause here because I know we were delayed by 10 or 15 minutes. So I do, as I say, once again, apologize for that. Now, these are very important. These you will not need to know. You will need to learn and understand why. So we have on March the 21st, June the 21st, September the 23rd, because of the calendar and the number of days in August and so on, and December the 21st, we have these important events where the sun is above the equator, or above the Tropic of Cancer, or above the equator again, or above the Tropic of Capricorn. And we will be studying this when we look at the motion of the sun a little bit more. We could put another column in here, the latitude on Earth of the sun. So for the spring equinox, we'd have 0 degrees, summer solstice, we'd have plus 23.5 degrees, and so on. Okay, we're keen to be getting on with some questions, I think, in a minute, some more questions. I've tried to edit some out and put new ones in so that this is new to everybody. So if we can have the next slide, please, Alastair, that will be great. There we are, just a little bit, just catching up there. So the tropics are the most northerly and southerly locations from which we can see the sun. So if you're further north from the Arctic Circle on December the 21st, you won't be able to see the sun. And the examiners gave us a not very pleasant question on that this year, again, as you'll see in a moment or two. Thank you, Alastair. Now, this is showing us what the relationship is between these 23.5 and 66.5 degrees and the tropics and the circles. I'll just let you look at this in a minute. We're assuming that the plane of the Earth's orbit is horizontal, and that's why two of the yellow arrows are slightly longer than the rest. So the Earth is tilted at 23.5 degrees to the vertical, or 66.5 degrees to the horizontal. Now, looking on the right-hand side, the sun's rays in winter. So the Earth's axis is tilted away from the sun, or certainly the northern hemisphere is tilted away from the sun. So the sun's rays come in and they hit a particular place, and that is the Tropic of Capricorn. So on December the 21st, the sun is directly above the Tropic of Capricorn, as you can see from the diagram, although the light's coming in from the right, and therefore that line of latitude, the sort of purpley line, has a latitude of 23.5 degrees south. Right, there's a question on this coming up shortly. Thanks, Alastair. Oh, we've got some more budding pupils here. So they're getting a little bit impatient. They want to see some past paper questions. So let's show you what kind of things they will ask you. Right, quite a few are multiple choice. Quite a few are just straightforward knowledge. So here we are. The autumnal equinox takes place on or close to, well, as we said, it's just about to come on us on Saturday. It will be at an exact time on Saturday, but we don't need to worry about that. So I'm hoping that most of you are going to, let's just have a check. It's always worth checking equinox and solstice. And I think the answer is C. So if Alastair will reveal the answer, please. We might need another one. We might need 2 clicks for some of these, Alastair. We might need only 1. And it was C. Right. So from which place on Earth would the sun be directly overhead at noon on the 21st of March? So the 21st of March, let's have a think about that, is the beginning of spring. So the sun is moving from the southern hemisphere to the northern hemisphere, and the answer is the equator, B. There we go. If you could pause for dramatic effect, Alastair, that would be brilliant. Thank you. No, this is an easy one. This is quite straightforward and a bit too trivial. People have divided the Earth's surface using several lines that have astronomical significance. Which line separates the Earth into its northern and southern hemispheres? It has to be the equator, doesn't it? Just double check. Not the prime meridian, that's the vertical longitude. It's not the tropics, either of them. I'm going for A, and there it is. It's all right, isn't it? Do chip in, everybody, if you disagree, or if you want to have a go yourself. Longitude of 0 degrees. Which line joins all locations with a longitude of 0 degrees? Well, that one, longitude of 0, is the prime meridian, the line through Greenwich and through the international date line around the other side of the globe. So let's hope we've got that right. B, we're looking for, Alastair. There it is. Brilliant. Okay, quite useful until we get to this. This was a question 3, noctilucent clouds. I don't know how many of you have heard of noctilucent clouds. I didn't till long ago, not long ago. And noctilucent clouds, I must say, are not mentioned in the specification. Noctilucent clouds, it tells us what they are. They're white clouds that shine brightly in the evening sky just after sunset. You usually see them sort of spring, early spring, May, June, July, that type of thing, I think. Those are noctilucent clouds. And it says that astronomers believe that noctilucent clouds are made when ice crystals form around pieces of dust in the Earth's upper atmosphere. Okay. Right, so what does the question say? Next one, please, Alastair. It says, observers at latitude greater than 70 degrees north can't see noctilucent clouds during the summer months. Explain the astronomical reason for this. Right, anyone going to go? Well, if we reveal the answers that are almost straight from the mark scheme, the location of 70 degrees north is further than the Arctic Circle, so you don't get a sunset. I think that's a very, very dodgy, unfair question. It's a trick, really. And you've got to be on the lookout for these. Right, let's move on, because time is getting on. Please, Alastair, thank you. Right, this is a little table and a little bit of analysis to do. This is quite common in the exam. I know we're only in week 1, but we're already looking at an exam technique for, 6 months or 18 months plus in the future. We've got 4 locations, A, B, C, and D, and some latitudes and longitudes, and the whole word has been written out this time. Analyze the data, so study it, just have a look, have a rummage through to determine which location has the sun overhead at midday on June the 21st. Midday on June the 21st. So June the 21st is the summer solstice. The sun doesn't really set for very long on June the 21st, even at these latitudes. So it's nothing to do with longitude, this one. And I think, and Alastair might like to just reveal, the answer is A. There we go. So the sun still rises and sets, but at noon it's overhead, and it must be lying on the Tropic of Cancer. This could be another question with maybe 5 locations, and you're asked to explain, not a multiple choice. So that'd be quite a nice one. Good. There are some nice questions in between my grumbles. Thanks, Alastair. Right, well, as I said, this is from a few years ago now, but I think it's worth putting this in. The latitude of tropical Capricorn is 23.5 degrees south. And we've got to show how that angle, how the value of the Tropic of Capricorn is related to the tilt of the Earth. So what I've done is to just cut and paste the mark scheme straight from the answer, straight from EdExcel. Thank you, Alastair. And there it is. So you've got the Earth's axis tilted at 23.5 degrees to the vertical. You've got the equator, but the light from the right-hand side, it's shown as that little dot, I think is supposed to be the sun. That little blob on the right-hand side is the sun. it's much further away and it's much bigger, but light is coming in along that angle and it's hitting that point on the Earth's surface, the Tropic of Capricorn. It's quite tricky, this 3D material. As I say, it'd be nice to have a good look at this again after the event. Right, thank you, Alastair. Just one or two more questions to come, I think. Now, you are going to have to submit a written record of observational skills, and I'll do a little flag up for the observational skills now. These are really important. You have to complete 2 complete projects involving designing, observing, analysing and evaluating. For 2 projects, one of which is naked eye or unaided and one of which is aided. Don't be thinking that one you can have help with and the other one you can't have help with. It's not that kind of aided. It's using an optical instrument. Now, one such, you don't get any marks for it. All the observational skills are not marked, they're purely endorsed. But and this is obviously a planning exercise, in the written papers, you get questions about the observational skills. So the more observational skill projects you try, and the sooner you start, the better for yourself. Now here we've got a group of students planning to make observations of a meteor shower. Obviously with the naked eye, it's very difficult to do it otherwise, unless you've got super duper cameras. The students expect the radiant to be close to their zenith. So the radiant is going to be high up, so we're not going to bother about trees and things like that in the way. And they've got 3 possible locations. Now, this is what you should be doing when you are planning all your observational skills. Look at different locations. They might not be practical. You might have different criteria. You might think, well, I'm not going more than 20 yards from my back garden or from the school playing fields. It's entirely up to you. We've got 3 locations here. And we've got the description. We've got any trees or buildings that might upset things. Remember, the zenith is close to the radiant is close to the zenith. So all the meteors will look as though they're coming from a point directly above. And then a little bit about light pollution. Right, so what the question asks, and we're not going to answer this at all, but we're just going to spend a little time just thinking about this. So the description of the location, we've got a hill about 4 kilometers from a small town, so there won't be much sort of light from the town, but there might around the horizon. Is that going to affect things if we're looking straight up? Don't think so. So this orangey sort of round the horizon sky glow isn't really going to affect things too much. Neither are the lack of trees and buildings. That's quite good. And a hill about 4 kilometers from the town. Okay, you got to walk there, got to climb up the hill in the dark. May not be all that safe. You might have a Land Rover and drive up, even better. Got the school playing fields next to the school in the middle of the town. We might have glare from classrooms. No, because school will have closed. Yes, because we might have evening classes, or we might have, outdoor five-a-side football with floodlights and things like that. Not brilliant. Or we might go to a deep sky park in Wales at Ellen Vale. No buildings, no trees, very little light pollution. Are we actually bothered about that? Are we actually bothered about seeing so many stars we can't actually jot a map down? So you've got to weigh this up and sort of give an answer. There's no correct answer. You know, I'm not saying Ellen Vale every time. That might be totally impractical. You know, if you live in the north of Scotland, well, you'll have your own dark sky parks there. But if you live in, say, the centre of London, it's going to be quite an expedition to get up to a dark sky park in Wales. And of course, when you get there, it's going to rain. Right, next slide, please, Alastair. That's just the sort of thing, though, to think about when you are. I've just done it in larger print there. So there we go. That will be a 6 marker. You get 2 6 markers on each paper. Right. Next slide, please, Alastair. We're nearly there, I think. Made up the time. Oh, we're back to the Earth now. So just to remind you that we could get questions on this. So we've got a cross-sectional Earth of the Earth and its major internal divisions: crust, mantle, outer core, inner core. Right. They did write a question once with 3 cores. Not quite sure what the middle one was called. Never seen it on a chart. Right. The questions appear if you just click on, please, Alastair, one at a time. Alastair's disappeared. Right. Which one has the highest average temperature? Well, a few slides ago, we said that the temperature and the density increase as we go downwards. So hopefully the answer will be, oh, Dom, you've given us a suggestion there. Brilliant. And I think you're absolutely right. The inner core. Excellent. So the next one, Alastair, is on the same slide, please. Which of the following layers, there are 2 of them, are entirely solid? And we're there again. Excellent. Well done, Dom. The crust is solid and the inner core. Remember, the outer core is a liquid, the mantle is a gooey mess. So I don't quite know what state of matter that is. Right, so let's move on to the next slide. I think we've got the answer from Dom there. Absolutely correct. Which one of the following is made of iron and nickel? Which one of the following lists all the internal divisions that are made of iron and nickel? We've not got to go into too much detail here that the mantle actually merges with the outer core. We've got to think of 4 distinct layers here. The mantle is not solid, Sean. Good try, but you're all right with the inner core. The inner core is solid. Right. If you want the other one, just bang the floor. Or go outside and bang the floor. It's the inner core. So the inner core. Sorry, I'm getting mixed up here. Sorry, I'm reading a different question. We're looking here mainly made of iron and nickel. Right. So what were you saying there, Sean? Just tell us again, please. Iron and nickel. It's the outer core and the inner core. You might think, well, where does the iron in mines come from? Maybe that's been brought by meteoroids crashing into the Earth. Dotty 4, the Earth's inner core is thought to have a mean diameter of 2,400 kilometers. There shouldn't be a gap there. It should be 4 digits that run on. Name the dwarf planet. Now, here you have to go to the pull-out sheet, the formulae and data sheet. So we've got to use information from that. So this is more a math skill, just checking to see which dwarf planet has a diameter that's closest to 2,400 kilometers. And I think you'll find it's Pluto. Can we have the answers, please, Alastair? D for the first one. Apologies, Sean, if I misread that and you gave the right answer and I didn't. That's one for you and one away for me. So we got Pluto there. Great. Thank you. Oh, we're back to, they're a little bit random, some of these, but then again, they are on the exam paper. Which one of the following is the line of latitude on which the sun is to pass directly overhead on the 21st of December? They've missed the st out there. On the 21st of December. The Arctic Circle, Dom's suggesting. I'm not sure about that. If it's the 21st of December, the sun is in the southern hemisphere, so it's going to be directly overhead the Tropic of Capricorn. Okay, Tropic of Capricorn. So the sun moves over the tropics, between the North and South tropics, passing through the equator. Right, it can't be over the Arctic and the Antarctic Circle. Thank you, Alastair. And that might be... I haven't got this presentation open. I'm looking at Alastair's version. If we press again, please, Alastair, we might find that we're there. Right. 2 more clicks, please. So we've actually made at the time pretty well there. I've been going at sort of quite a speed to get everything in, and so we can finish in a reasonable time, because some of you have got football matches to watch. I know Alastair and myself have. So thank you for appearing and taking part, and thank you for your participation, everybody, today. And we hope you found it not just useful, informative, but inspiring. I hope you're going to think, oh, what I'll do is I'll read this all again, the whole chapter in the book, a couple of times. I'll watch the presentation again, and I'll reread the book again, and then you should have a good, solid grounding in this. And 2 more clicks, Alastair, please, and we'll have our final little zoomed message. And there we are. We hope to see you again next month. And thank you very much, everybody, first of all, for attending, but more importantly, for your patience in my computer. I thought I'd got it all working and up and running. It's just too clever for me.